Before I show you the more complex starter schematics, let's review the information circuits video from the intermediate course. I'm going to show you that once you understand the basic electrical circuits like the power side switch over here and the ground side switch over here, the module information circuits are really not any more difficult. Sometimes what makes it seem harder is that there are so many information circuits on cars today. Some cars can have 50 to 100 or even more information circuits just to have the module know the status of a certain switch, the position of the accelerator, the position of the throttle, the temperature of the coolant, the temperature of the air at the intake, the temperature in the ducts for your AC system. There are information circuits for most of the switches on the car, and all of these in most cases will each have their own circuit. The good news is it's still power, load, and ground. So let's take a look over here at the power side switch and the information circuit that's the power side switch. If I was to look at the numbers, the voltage numbers, notice how I have a switch on the power side here, a switch on the power side here, and when I close the switch, notice how the voltage changes, and now I either power up the bulb, or in this case, I provide 12 volts down to where this meter is here. So inside the module, there's actually a meter on every one of these circuits monitoring the voltage. In the regular circuit here, when I open and close the switch, the light lights up or turns off. But in the information circuit, notice how the voltage just changes from 12 to 0 on this wire that's being monitored. The BCM knows the position of the switch. It knows if the switch is on or off. If the switch is on, the voltage would be 12, and if the switch is off, the voltage would be 0. And the only difference on the ground side switch, now let's come over here to this side. On the ground side switch, I have 12 volts past the load, just like I do over here. I have 12 volts past the load, and then when the switch closes, this reading up here is going to change. That reading right after the load is going to change. So let's watch that. So notice how that changes from 12 to 0 right after the load. This time, inside the module, we have the load here, which is just a resistor. And this resistor can be a high resistance, which would allow very low current and very small wires to be used by the module. So we don't need to waste any power. We just need a way to monitor that the voltage changed. So this resistor value could be 1,000 ohms, it could be 2,000 ohms, 10,000 ohms. They can choose whatever value they feel they want to within certain limitations, but they're only trying to make a circuit using this resistor as the load so that they can monitor the change in voltage inside that circuit. Once the switch is closed or open here, notice that there's a different reading on the ground side switch. So on the power side switch, we had 12 volts means closed and 0 volts means open. But on the ground side switch, we have 12 volts means open and 0 volts means closed. So the modules are just programmed to know that information on which type of switch it is. And if there were multiple switches for a specific circuit, it would know all of that information programmed in by the manufacturer for all of the different switch circuits. Now for us, when we're diagnosing them, we just need to know if there's a fault in that circuit, or if there's a fault where why is the module not turning on a circuit. Maybe it doesn't think that the switch is being pressed, or maybe there is actually a fault in the switch itself. Diagnosis becomes more of a three-part process because you have an input circuit, the circuit that provides the information, you have the module or the decision maker circuit, and then you have the output circuit or the device that is being activated, or the load that you actually want to work, like a relay or an injector or whatever it is.